This video is going to be focused on solving applications to systems of equations using matrices. Now, before I jump into that, I want to make sure that we know how to rearrange a matrix into standard form. So I'm going to go over that very quickly. So, for example, if you have a matrix that looks like this, I'm just going to make one up real quick. Negative 5x minus z equals negative w minus 2y minus 18. 3w plus x minus 3. So say you have this system of equations and you need to plug it into a matrix. Well, you first of all have to have all this stuff in standard form. So let's go ahead and put it in the form of w, then x's, then y's, then z's, then equals, then our numbers. Okay? So again, always you have to have your numbers on the right side of the equal sign, all your variables on the left side. Doesn't necessarily matter which order you put the variables in, just as long as they are vertically lined up. I'm going to do w, x, y, z. Okay, so if I'm going to do that, I'm just going to talk about a trick. It's not, it makes complete sense to those of us that know how to actually solve these things. If I'm going to get rid of a negative w, if I'm going to move it to the other side, I have to add that w. Alright? So the way I usually remember it is if I need to move something over the equal sign, it's going to change signs. So that negative w is going to become a positive w when I move it to the other side. So starting off, let me just rewrite these equations just to the right here. Okay, so I'm going to start off with this first one. I'm going to have w. I've got a minus 5x already on the correct side, so it doesn't change. Minus 5x. It's not moving over the equal sign. I need to get this negative 2y to the other side of the equal sign, so that's going to become a positive 2y. I need to get this negative z to the other side of the, no, it's on the right side of the equal sign, so we're good. So it's still just a minus z. And then that negative 18 is on the correct side of the equal sign, so that's going to stay where it's at. That's supposed to be a negative 18. Kind of tough to see. Alright, so there's one equation. Next equation. I've got the 3w. Well, look, that's w, x, y, z already, so I'm just going to rewrite this equation real quick. 3w plus x minus 3y minus 2z equals 17. So that one was ready to go. It already had w, x, y, z in order. This one, I've got to get everything on the other side, it looks like. W has to move over the equal sign, y has to move over, x has to move over, z has to move over. So, start off with this 4w. It's going to become positive 4w. My x is going to be negative 2x. My y is going to be a positive y. My z is going to be a negative z, because all those had to move over the equal sign, they all switch signs. This 1 has to move on the right side of the equal sign, so it's going to switch signs. So it's a negative 1. Alright, and then lastly, I've got to get this 2w over here, and I've got to get the y over there. I've got to get the 11 on this side. So, 2w is going to be a negative 2w. X is going to be, it stays, so it's just the same. It's a positive 3x. Y, this y has to move over, so that's going to be a negative y. And that 4z is staying on the left side of the equal sign, so it's still positive. Plus 4z equals, and then that negative 11 has to move over the equal sign, so it's going to be a positive 11. Anyway, here are my equations now. I got my w's, my x's, my y's, my z's, my equal signs, and my numbers all vertically aligned. So I'm ready to go. If I plug that into a matrix, it would be, well, sure, I'll just rewrite it real quick. Let's do it that way. So here's my matrix. I've got 1, 3, 4, I needed a bigger matrix. Negative 2, there we go. 1, 3, 4, negative 2. I need negative 5, 1, negative 2, 3. Negative 5, 1, negative 2, 3. I need 2, negative 3, 1, negative 1. 2, negative 3, 1, negative 1, and then I need negative 1, negative 2, negative 1, 4. And then I need what they equal. Negative 18, 17, negative 1, 11. Oops. So there it is. Those are these 4 equations written as a matrix. 4 rows by 5 columns. Okay. Now, with that being said, you're going to need that skill when you start going into real-world applications. So, for example, let's go ahead and get this first one. The baseball shop sold 10 balls, 3 bats, 2 bases for $99 on Monday. 4 balls, 8 bats, 2 bases for $78 on Tuesday. 2 balls, 3 bats, 1 base for $33.60 on Wednesday. What is the price of each ball, bat, and base? Well, that one actually not so much. That will probably be pretty easy. So let's use A, B, and C for balls, bats, and bases. So I've got 10 balls plus 3 bats plus 2 bases for $99. 10 balls, 3 bats, 2 bases for $99. 10 balls, 3 bats, 2 bases for $99. Next, 4 balls, 8 bats, 2 bases. 4 balls, 8 bats, 2 bases. Oops. Bases is supposed to be a C. For $78. For $78. Next, 1 base. Oh, 2 balls, 3 bats, 1 base. 2 balls, 3 bats, 1 base for $33.60. So if I'm going to solve this using my matrix, I need to make sure they're all in order. So we got A's, B's, C's, equal signs, and numbers on the other side. Great. So it's ready to go. I don't have any rearranging that I have to do. So 10, 3, 2, 99, 4, 8, 2, 78, 2, 3, 1, 33.6. So there's my matrix. Now I'm going to go ahead and plug it into the calculator and get my answer. So on the matrix video, I show you how to actually plug it into the calculator, so I'm not going to necessarily waste time talking about that. We've got 10, 3, oops, I'm plugging it into the wrong spots. 10, 3, 2, 99, 4, 8, 2, 78, 2, 3, 1, 33.6. Solve it. So it says that the price of a ball, so A, which is A, the price of a ball is $8. $8 for a ball, that's crazy. Okay, so the price of a ball is $8. The price of a bat is $5.4, and the price of a base is $1.4. Okay, so there's the solutions. It's done. Unfortunately, this problem seems a little unrealistic, but they're the solutions nonetheless. Okay, let's go on to hopefully a more realistic problem. I'm not going to spend time doing this. I'm going to... it's something that probably needs to be covered a little bit, but not so much. Not for the scope of this video, I guess. I like this one right here, geometry problem. So, find the measure of 3 angles of a triangle if twice the measure of the first angle. So let's use A, B, and C again. Twice the measure of the first angle. So 2 times A, twice the measure of the first angle, plus 3 times the measure of the second angle. So plus 3 times the measure of the second angle equals, okay, well that's straightforward, equals the measure of the third angle. equals the measure of the third angle. So there's one equation. And if the measure of the second angle is 3 degrees, so the measure of the second angle, so that's B, is, so measure of the second angle, where'd they go? Is, that's the equal sign, 3 degrees more than the measure of the first angle. Well, here's the first angle. Right now it says the second angle is the same as the first angle. That's not true. The second angle is the first angle, but it's 3 more than the first angle. So I gotta add 3 to the first angle to get it to be the size of the second angle. Alright, so there's 2 equations. Now the problem is, if you've got 3 variables, you are going to need 3 equations to solve for those 3 variables. So we're missing an equation somewhere, and there's no more info in this problem. The thing that you have to do is you read it between the lines a little bit. So it tells you that it's a triangle. The thing is, we know that the 3 angles of a triangle will always sum up to be 180 degrees. So if I take A plus B plus C and add them together, then all those angles added up should be 180 degrees. There's my 3 variables. That's a little bit of insight with systems, by the way. If you have 2 variables, you're going to have at least 2 equations to solve them, or you need 2 equations to solve them. If you have 3 variables, 3 equations. If you have 50 variables, 50 equations. Okay. So this and this I need to put in the right order. So 2a, let's go ahead and start with the top. 2a, 3b, so I need 3b. And then that c is on the wrong side of the equal sign. I need to get it on the other side, which means it's going to become negative. So there's a negative c. Now when that moves over the equal sign, I'm left with nothing over here. So I've got 0. Okay, so there's my other equation. I'm getting my a's, my b's, my c's, my equal signs, and my numbers all lined up. So here's an a. I need to get this on the other side of the equal sign. So that's going to become a negative a. So I've got a negative a. I've got a b. I don't have any c's. And that's going to be equal to 3. I want that number to stay on this side. So I've got a negative a, I've got a positive b, I don't have any c's in this whole equation. It's going to be equal to 3. There's my 3 equations set up, pretty much ready to be plugged into a matrix. I'm not going to rewrite it. I'm hoping we're catching on by now, but it's the matrix that you plug in is going to be 1, 1, 1, 180, 2, 3, negative 1, 0, negative 1, 1, 0, 3. Alright, so let's go ahead and do this one. This one can be a little bit tricky. The sum of 3 numbers is 6. Alright, great. Let's call it A, B, and C again. A plus B plus C equals 6. The third number is the sum of the first and the second number. Okay, so the third number, which is C, is, so C equals the sum of the first and second number. So the first and second number added together, the sum of them. Alright, I'm going to have to change that to fit this order in just a second. The first number is 1 more than the third number. So it's comparing, these are always tricky to people. It's comparing the first and third number, and understandably so. So the first number is 1 more than the third number. Most people want to say, oh, well the first number is 1 bigger than the third number. And that's true, and so they think this, but that's not actually the true statement. The way I teach it is say, okay, it's comparing A and C. It's comparing the first number and the third number. It says which one's bigger. A is bigger than C. Right now we say that A is equal to C. So which one's smaller? C is smaller. If C is ever going to equal A, I need to add to that one. This has got to be a true statement. So that's how you actually write it. C has to be added. You got to add 1 to C if it's going to be the same size as A. Think about it this way. If A was bigger than C already, if I added more to A, it's going to be even more big. It's going to be even further from C. So I've got to add to C to actually make these things equal to each other. Now I've got to rearrange. So I'm going to subtract A to the other side. I'm going to subtract B. Well, let's start with this equation right here. So A is fine. I'm going to subtract C to the other side. I don't have any B's, so 0B. Subtract C to the other side. So that gets rid of that. And that 1 needs to stay on this side of the equal sign. So here's A, 0b minus c. So A plus 0b minus c equals 1. Alright, now let's solve this top one right here. Pretty much I'm just moving the A and the B over the equal sign. So I'm going to have negative A minus B plus C equals 0. Both the A and the B had to move over the equal sign. So I've got negative A, negative B plus C equals 0. Negative A, negative B plus C equals 0. Well, there are my three equations. So my matrix looks like 1, 1, 1, 6, 1, 0, negative 1, 1, negative 1, negative 1, 1, 0. Okay, so if I plug that into my calculator and tell it to do the reduced row echelon form on there, it's going to give me the answers. Okay, so I think that's good enough for this video. I don't really want to spend too much more time on this paper. So hopefully you understand now a little bit more about pulling information out of problems to write equations and then plugging it into a matrix. The next video is going to be about just writing the equations. So because hopefully by now, once you have the equations written, you can actually plug it into a matrix and have the calculator solve it for you. So the next video is going to be solely writing the equations. Alright, so thanks for watching, and I will catch you guys in class.